In this video on standard form, I'm going to go through some essential calculations you'll have to do with standard form. If you haven't seen the previous videos on standard form, please do watch them. If you feel confident enough to do the questions in this video, please continue watching. So with operations in standard form, you'll have the typical multiplication, division, addition, and subtraction. Multiplication and division will be quite easy because you can use the laws of indices. And in some cases you can use your calculator if it's in a calculator paper. As for addition and subtraction, there are some additional steps you'll have to go through to be able to do the questions. Once we're done with these questions, do attempt some more that are available in your book and the exercises at the end of the chapter. So I'm going to go through the multiplication and division, just two of them, and then you continue with the rest. With multiplication, keep in mind that everything's being multiplied. So if I swap these around in any case, if I swap the 10 to the power of 3 with the 3 and I write it as so, it's still the same equal expression, because multiplication is what we call a commutative operation. It doesn't matter where you put the numbers, the answer will still be the same. So I could do 2 times 3 and 3 times 2. It doesn't matter if I swap them around. And the same thing here with standard form. Now it doesn't look like standard form anymore, but it's still a multiplication, which means you can easily multiply the numbers. 2 times 3 would be 6, and then you use the laws of indices for this part. You have 10 to the power of 3, 10 to the power of 6. You have a multiplication. You have the same base, which means you can add the powers. And so you have 10 to the power of 9. You don't need to write this whole expression. You can immediately look here and go, well, yeah, it's 2 times 3, and then I need to add the powers. So you can attempt the rest of the multiplication ones. And then for division, again, it's the same idea. It's just that I'm not going to swap them around. I'm going to write them in a fraction form. Times 10 to the power of 12 divided by 2.2 times 10 to the power of 8. In this case, you'll have to do the A part separately, so this part separately, and then you'll have to use the laws of indices again for this part. You have 8.8 divided by 2.2. 8 by 8 divided by 2.2, you can use long division, or you can use simplification if you want to. You can change them as well to be 88 divided by 22 if you want to, but the answer is 4 in this case. And then 12 and 8, well, you have a division sign. You have the same base, which is 10, and so you subtract the powers, and 12 minus 8 will be 4. So it's 10 to the power of 4. If you are using a calculator, it's in a calculator paper, and you want to check your answer, you can easily do that. So for the first one, and I'm using a TI 84 Plus calculator, for the first one, it's 2 times 10 to the power of 3. And in order to write the times 10 to the power of 3, you'll have to use second, and then you press the double E, which is on the comma button, and then 3. So this basically says the E represents the times 10, and then this 3 represents the power. So 2E3, and then multiplied by 3E6, and you end up with a really big number. You can change this to standard form. You can change your calculator to write in standard form by going to standard form. Scientific notation, so that's why I press standard form. So it's already telling me that 6 to the power of times 10 to the power of 9. So again, you have to go to mode and then go to scientific. And then we can try with the division as well. So 8.8 to the power of 12 divided by 2.2 to the power of 8. And it should give us 4 times 10 to the power of 4. So these things are easily checked in a calculator as well. As for addition and subtraction, you can't just add and subtract the numbers straight away. because they don't line up, basically. You have more zeros in this number than this number, which means the decimals don't really line up. And so the best way in this case is either to write it as an original number, so non-standard form, or you can change to make the same power, or for them to have the same power. I'm gonna try both. So for part F, I'm gonna try both methods. Method 1, I'm gonna change them to normal numbers. So I have 8,900, and then I am adding I'm adding 31,000. So adding these numbers up, it would be easy to see that it is okay, 39,900. So then you'll have to write it in standard form again, especially if the question says solve and then write in standard form. Typically, they do expect you to keep it in standard form unless they say otherwise. So this would be 3.99 times 10 to the power of 4. Now, the other method is to have them have the same power. I could change the 3.1 and to have a power of 3, or change the 8.9 to have a power of 4. Either could happen. To have this have the power of 4, I'll have to move the decimal point even further down. So you end up with 0.89 times 10 to the power of 4 plus 3.1 times 10 to the power of 4. Well, now that you have the same power of 10, I can easily add these two numbers. That's the whole idea. So I can do 3.1 plus 0.89, and I end up with the same thing. Bring the decimal point down, and then remember that you are multiplying by a 10 to the power of 4. So that's your final answer. Again, we got here. You can also change it to, you can change the 4 to be to a power of 3. So we could have done 8.9 times 10 to the power of 3 plus 31 times 10 to the power of 3, because moving it one step to get 3.1 would get us to 10 to the power of 4. If you're not convinced by this step, do expand this back and then expand it to have, change it back to the original and then write it such that it's times 10 to the power of 3, and you'll notice that it will be 31. And then you can add the numbers the same. You won't get the number in standard form, so in this case you will get 39.9 times 10 to the power of 3, which is not in standard form, so you'll have to change it to standard form to get 3.99 times 10 to the power of 4. So, and then it's a similar case with the subtraction. You just change them to have the same power, and then you subtract the digits. So it's not impossible to do, it just requires that extra step, and be comfortable with any of the methods that I've gone through. Sorry for the mess on this page. Have a go at the questions. These solutions will be on the next slide, so do pause this video now. So these are the solutions to the questions. Make sure that you check each one and the power and the A value. Be aware that some calculations, for example, similar to part A and E, and the addition and subtraction are some things that would appear in a non-calculator paper because they're quite easy to calculate. But things like dividing more complex numbers, you would expect in a calculator paper. But do try and attempt them on your own, and you will expect to know how to do these either with a calculator or non-calculator, but obviously simpler numbers in a non-calculator paper.